By the end of this video, I will expect you to understand what a tiebreaker looks like, how to seek a tiebreaker, and at least one situation when seeking a tiebreaker is an appropriate step to take. We just found that inclusion of photo in collection is an intersection entity between photo and collection, and found that each instance can have a position and a caption. That's a two-way intersection entity with descriptors. Here's that point in the standard flow, two-way intersection entity with descriptors. The next step is seek tiebreaker. Tiebreaker is just a shorthand for additional identifying descriptor. So we could have just named this step seek additional identifying descriptor. Or we could have called it consider under identification, which would be cohesive with the name of the next step, which is called consider over identification. However you like to think about it, what we'll be doing in this step is asking a yes or no question to determine if we should add another descriptor to the identifier. The yes answer has two paths, depending on whether that descriptor is an attribute or a link. What's with this term tiebreaker? It's intended to be a sports analogy where two teams have a tie, and therefore their standing is undetermined, and they must make a tiebreaker play to resolve the match. Similarly, if we know we have two data instances with the same identifying values, then the difference between them is undetermined, and we must find an additional identifying descriptor, or a tiebreaker, if we want to resolve the matter of under identification. It's not a perfect metaphor. To seek a tiebreaker, it always helps to anchor your understanding with instances. We're working on an intersection entity. Two great ways to draw instances for an intersection entity are by drawing connected dots or just drawing a table. Either style will be helpful for discussing tiebreakers. As always, we will focus on just one instance, and now we'll add a duplicate instance. That would either be a duplicate row in the table or a duplicate line that connects the same two dots. And we will ask the users, can two inclusions in collection have the same photo and the same collection? Or can a photo be included in the same collection more than once? If the users answer no, it would mean having two such connections is not allowed or not possible. In that case, we would make no change at all, no tiebreaker, and we would maintain our two-way intersection entity. If the users answer yes, then we would need a way to tell those two instances apart. That would require an additional identifying descriptor or a tiebreaker. Perhaps this photo could be positioned in this collection twice. If we think of positions as numbers again for now, we could say the photo appears once in a collection in position 1 and again in the same collection in position 75. If we decided that position can act as an identifying descriptor, then we could distinguish the two instances. As a result of that question, all we are doing to the model is possibly adding a bar under this existing attribute if the answer was yes. Returning to the flow, we are at the step of seek tiebreaker. If the users answered yes, that takes us down the bottom path for finding a two-way intersection entity with tiebreaker attribute. If the users answered no, that takes us down the middle path, which leaves the model unchanged without a tiebreaker. What about the top path? This is a different yes answer. It says we find a tiebreaking link, which gives us a three-way intersection entity. For that, let's go to a different example. In this model, measurement is also an intersection entity. Suppose we just discovered that and now want to consider a tiebreaker. We can ask the same kinds of questions as before. Can two measurements have the same operator and the same gauge? The answer might be, yes, we measure many different dimensions of our product, so an operator might use the same gauge to measure different dimensions. For example, length, width, and height. This answer is revealing the need for a tiebreaker, but it's not entirely clear how it should look. We could add a dimension attribute, or we could link to a dimension entity. Probably the best way to get an understanding from the users is to look at instances. So let's return to our table of instances and start with the simplest possible action, which would be to add an identifying descriptor column for a dimension. And we could ask the users to help us fill in data. Because we're adding an identifying descriptor, I've added an extra row at the top with identical values for a gauge operator pair. This way, we can put the users to the test to see if they can come up with an example that proves the need for an additional identifying descriptor. Notice, I left non-identifying values blank. I don't want to make any assumptions about what the data looks like. If I copy and paste all the data from other measurements by John with ruler, then it might be misleading or confusing. I could have left out gauge and operator as well, but I wanted to at least set up a clear example of what I'm looking for. After our conversation, you might be able to fill in data like this. You can see that we ended up with dimensions like length and width. Also, I'm glad I did not just copy the 35.3 centimeters up here, because that would have been unrealistic data and could have led the users to think that they should enter length again as an example dimension, which would have created confusion. Clearly this product is long and skinny, and the users know that. We haven't really decided yet if dimension is an attribute or a link. Of course, we can just default to treating it as an attribute, but suppose that as we were discussing this, a user brings something up. Oh, also, we need to remember the nominal value for each dimension. We could have them help us write down instances to understand what nominal values are. Here we see the nominal value is sort of like a targeted or a designed value for the dimension, and the actual real-world measurements will vary from that. We know it's part of the dimension and not measurement, so we can tell that putting dimension in a separate linked entity is appropriate. Okay, we're now juggling a bunch of new ideas at once. We were trying to seek tiebreaker for measurement, but now we're looking at a new entity with multiple descriptors for that entity, unknown identifier, a relationship between the measurement entity we started with and this new entity dimension, with unknown degrees on both sides of that relationship. And should we be putting a bar on that relationship to address that tiebreaker? This is too many variables to manage at once. In data modeling, although we want to allow the users to drive the decisions, we don't want to get carried away. Instead, we always want to prefer controlled evolution. So out of all of these concerns, which do we address first? As always, we want to stay grounded. Entities are more grounded than relationships, so let's get the new entity established first. In fact, let's go exactly in this order. Okay, dimension. I think you mentioned a nominal value. What should we remember about each dimension? Yes, each dimension has a name and a nominal value. Okay, so we don't get confused with other names later, can we call this dimension name? Sure. Now, as a modeler, time for more judgment on our priorities. Normally I would now ask, what else should we remember about each dimension? But we still have all of those measurement related issues on hold waiting for answers. If we start asking what else, it might open yet another rabbit hole. Again, we want controlled evolution. So before opening up any more doors, let's continue to drive toward that tiebreaker. So we want to know about the identifier sooner if possible. How do we distinguish two dimensions from each other? Let's say the users answer, I think we could come up with a unique name for each dimension. Okay, let's put a bar here. Now I think we were saying that there is some association between a measurement and a dimension. Yes, each measurement is for a particular dimension. So we just discovered a relationship, and I add a line with question marks on both sides. Can a measurement have more than one dimension? No. But a dimension can be measured many times. Yes. So did you say that we could have two measurements that have the same operator and the same gauge if they have different dimensions? Yes. Now finally we've achieved our tiebreaker by making a three-way intersection entity. The third identifying link to dimension is our tiebreaker. This process might have been a lot faster if dimension were already somewhere on our model. Then we could have just linked to it. But in this example we went through the entire discovery process for dimension, which is actually very common practice at this step. It's typical that users will only stop to think about tiebreakers when asked these very specific questions, which might mean you'll not discover these entities until you get into tiebreaker discussion. We've now seen two examples of tiebreakers, one as an attribute and one as a link. In both cases we started with a two-way intersection entity, and in both cases we ended up with a third identifying descriptor. Adding tiebreakers and going from 2 to 3 bars is part of the standard flow for two-way intersection entities. But fundamentally all we're doing is adding a bar. Adding a bar can happen anywhere on the model at any time. For example, it's possible that the photo entity is under-identified with only a single bar. It might need a second bar, and the procedure for checking that is the same. So remember that seeking tiebreaker is actually an anytime, anywhere evolution. It's our job as modelers to keep the big picture in mind and notice potential situations where a tiebreaker might be needed. Now check your understanding.